So we will begin, insyaAllah. Kelas rep ada kan?
Ada sir, ada.
Okay, saya take over lah. Bismillahirrahmanirrahim. Alhamdulillahirrahmanirrahim. Ar-Rahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, chapter 12, DC circuits. So before we actually begin, I believe the Kirchhoff laws are actually new to you, Maknanya sebelum ni explore ke? Not in your SPM ITIC syllabus, Okay, that's quite interesting lah. So we've got two Kirchhoff laws, Kirchhoff first law and second law kan? Ataupun kalau dalam bahasa engineering sebenarnya lebih senang kita define as KCL ataupun KVL, Kirchhoff current law and Kirchhoff voltage law. Tapi kita just boleh nak kata Kirchhoff first law ialah current law, second law ialah voltage law kan. So walaupun sebenarnya kalau if you notice the practice questions yang ada tak sentuh sangat lah secara eksplisit on the Kirchhoff laws, is rather more on the potential difference kan, potential divider circuits kan. Tapi sebenarnya even dealing with potential divider circuit, the same laws, Kirchhoff voltage and Kirchhoff current, still govern the entire calculations, as you can see later. Nanti kita akan cuba discuss bersama insyaAllah. Okay, so hopefully we can go through this together. So question number 1, a DC power supply of EMF 12 volts has an internal resistance of 2.3 ohms. It is accidentally shorted out across its terminals by a short length of wire of negligible resistance. Okay, so can anyone draw the circuit that is referred to in this question? You can annotate. You can request for annotation. What was my question again? My question was, can any one of you draw the circuit of this power supply, DC power supply having an EMF and having an internal resistance? Okay, thank you, Alif.
I'll try, sir.
Yep. Go for it. Okay, so Alif is on purple. Allah. Are you done?
Yeah.
Okay, so can you label the circuit?
Okay.
In terms of values lah.
Okay. So difficult. So ugly.
The struggle is real, isn't it?
Yeah.
Okay, thank you very much. Okay, thank you very much, Alif.
Oh, dah, okay.
You have a simple circuit, power supply, lepas tu short circuit, macam tu saja without any resistance connected through it Okay, thank you very much. It's a very good drawing. But how can we improve on this drawing? Anyone? Anyone? No? So are you guys contented on this drawing? Maknanya semua agree ke? This is the drawing?
ada internal resistance.
Yes. We need to label ataupun we need to have the component of the internal resistance together. Although this is a short circuited punya equation kan. Yes. Thank you, Alicia. So we would label ataupun we would draw the EMF power supply sebab dia bezakan EMF dengan PD. Kalau EMF dia akan ada the internal resistance lah selalunya. Oh, Iqbal lagging eh. Okay. So Kalisha is drawing. So kalau dalam notes kita kan dia ada dashed box kan untuk nak represent the entire EMF power supply. Yang mana EMF power supply tu dia akan ada dia punya DC punya power supply as well as the internal resistance. So beza a normal PD dengan EMF ialah pada dia punya internal resistance. So kalau kita ada normal PD, the voltage that is stated as the potential difference, 100% it will be converted lah to the entire potential difference across the circuit. Tapi kalau EMF, although it is stated as 12 volts, sebenarnya effectively dia bukannya 12 volts kan, because akan ada kita panggil sebagai voltage loss. Okay, thank you very much Alif and Kalisha. Okay, so proceed kat sini. So this is the circuit that is drawn in the notes, okay, provided in the notes. So kalau kita tengok kat sini, sebenarnya circuit concerning EMF ni is just like a simple circuit that contains two resistors connected in series. You've got the external resistor, capital R, as well as the internal resistor, small letter r. And then we've got E. Cumanya bila dia adalah EMF, so we have that this dotted box. Okay. So dotted box kat sini. So the potential difference stated as its power supply, E, would not be effectively that value that is being supplied to the entire circuit. Sebab apa? Sebab kita akan ada VR kat sini kan. So VR kat sini yang akan create inefficiency of the EMF supply. Okay. So even in this circuit pun sebenarnya we can explore Kirchhoff voltage and Kirchhoff current law. Okay. Can anyone state to me, given that we are here, the potential difference across the internal resistor, we assume it as VR, small letter r, and then the potential difference across the external resistor as V, capital R. Okay. Can anyone quote for me KVL, Kirchhoff voltage law, here? You can either say it out loud ataupun you nak annotate pun boleh, tapi say it out loud pun boleh juga sebenarnya. Anyone? What is Kirchhoff voltage law kat sini? Ataupun Kirchhoff's second law? Anyone? Nobody? Aduh, tak dapat siapa lah. Okay, so Kirchhoff voltage law states that the total voltage supplied into the circuit must be equal to the total voltage of output across each electronic component. So maksud dia punya Kirchhoff voltage law tu atau Kirchhoff second law, dia akan bagi equation E is equals to VR plus VR. So that is Kirchhoff voltage law. That's two. Okay. So yang ni tak ada kaitan dengan soalan tu. Kita just nak revisit dia punya dia punya concept first. Okay? Okay. Kirchhoff voltage law. Hello, are you guys with me?
Yes.
Ini awfully quiet, you guys. Buat puasa ke? Awak lagi. Baru 11.
Tu lah. Aduh.
Okay. So now the question is asking, calculate the current drawn from the supply. So we can actually calculate the current drawn from the supply because they ada internal resistance, although they short circuit. Okay. So the of the current, kalau kita ada ni waktu budak ni punya masa untuk nak tidur jugalah sebenarnya. Sama macam siapa-siapa yang ngantuk. So siapa yang ngantuk sekarang is sebiji macam budak kecil ni. Okay, so the current I equals to E over R plus R. Why R plus R? Because the resistors are connected in series. Cumanya, this current, this circuit, in this question, dia short circuit. So can anyone draw me where is the short circuit happening? Kat mana dia short circuit? Dia kata, it is accidentally shorted out across its terminals by a short length of wire of negligible resistance. So dia short circuit kat situ. Can anyone draw me the wire in which dia akan berlaku je short circuit? In the circuit kat atas tu. Anyone? Hello, hello, hello. Okay, thank you Kalisha.
Wait. I'm not sure. I don't know.
Okay, thank you very much. It's okay, you can actually try.
Try.
Macam mana nak draw short circuit? Jauh. Is that you, Kalisha? Did you just draw? Okay, thank you very much. And there is a process of learning, inshallah. So anyone else? Do you guys agree with Kalisha's drawing, or would you beg to differ?
I'm not sure as well, so.
I see. Okay. Anybody else? Shazwina tadi request for annotation. You wanted to answer ke?
I agree with Kalisha, sir.
Sir, can I try, sir?
Yes, you can.
Like that, sir.
So how does that differ from Kalisha's drawing just now and the one that was agreed by Shazwina?
It has no resistance. They direct to the battery.
Tapi yang tadi Kalisha pun sama juga kan? Dia draw the purple line. No? Ke saya tersalah tengok? So, do you guys understand my question sebenarnya? Okay, thank you very much Iman. Lost sikit kan? Soalan pertama dia cakap pasal short circuit. Kita nak cuba elakkan jadi short circuit. Sekali soalan circuit lah pula. It's okay. Thank you very much everyone. Okay, so let's zoom in into this problem. Okay, so this is our EMF connected to, let's say, an external resistance. Lepas tu soalan dia kata, accidentally the power supply is short circuited. So where is actually the power supply? Is it just E? Memanglah ni power supply kan? Cumanya dia EMF power supply. So kalau dia EMF power supply, maksud dia apa? It must contains the total power supply along with the internal resistance R, small r here. Okay. So they short circuit between the terminals. The terminals is not the terminal of the DC battery kat sini saja. Sebab dia EMF power supply. So the terminals are actually this point as well as this point. Faham tak? So short circuit dia kat mana? Sorry. Short circuit dia akan berlaku
Along wire tu ke, sir?
Ya, katakanlah kita ambil kat sini lah walaupun dia kata short wire kan, tapi dia akan jadi macam ni. Faham tak? Okay. So the current generated by the EMF power supply, dia akan go to this junction, and bila dia jumpa this junction kan, dia macam apa, siapa nama yang poem tu? Alah, start with E. Dia kata yellow road, two roads.
Waldo Emerson.
No, that guy yang two roads diverge in a yellow wood, something like that.
I don't know.
Benda form 4 kan, tahun 2002 lah. Probably literature dah progress lah kot kan, dia tak guna literature.
I think Dumbledore.
Ni, if you notice, current yang lalu bila dia jumpa this node for example, so dia ada choice this current has got a choice. Either he wants to go to the external resistor down kat sini, ataupun dia nak yang less resistance kat sini. So because this is a short circuit, dia akan dekat yang ada resistance. Okay, dia akan pergi yang dekat tak ada resistance. Kenapa dia tak nak pergi dekat sini? Kenapa dia tak nak pergi yang dekat ada resistance? Because that is the tendency of the current. Dia akan tengok kat mana yang tak ada resistance langsung. So bila dia short circuit, apa yang berlaku ialah the current generated from the power supply, dia akan masuk kat sini. Bila dia jumpa kat node, dia akan terus, almost all of the current will be flowing into the wire ataupun into the branch yang tak ada resistance langsung. Yang dia kata length of wire of negligible resistance kat sini. Dia akan masuk kat sini. So that's where the short circuit occurred kat situ. Dan kat sini pun kita boleh tahu dia punya Kirchhoff current law, KCL, Kirchhoff's law. So for example, kita ada incident I generated by the EMF. Kemudian kita ada I capital R, resistance R. And kita ada I short circuit kat sini. I'm sorry, I'm drawing with my left hand because my right hand is actually dengan budak kecil yang apparently dah tidur for some reason. Physics is like a lullaby for him and for most of us kan. I is IR plus IS. Cumanya in this case IR will be almost equals to 0. I dia akan conserve entirely to IS. I equals to IS kat situ. So ini tak ada kaitan pun lah dengan soalan ni. Ini just for understanding lah. So hopefully this does not confuse you further. Cumanya untuk nak visualize kan where does the short circuit occurs. So the short circuit occurs at the terminal of the EMF. So EMF contains the DC supply as well as the internal resistance, not just the DC supply E. Faham Please remember that. EMF dia akan contain dua komponen. Satu, the total E. Nombor dua is the internal resistance kat situ. I guess, yeah? Boleh?
Boleh.
Since R is the power supply, is short circuited, then R equals to 0 ohms. So I is equals to 5.2 amperes. Okay. Alright. Suggest why it may be dangerous to have supply shorted out in this way. Siapa nak berhujah? Why it may be dangerous to have a supply shorted out in this way? Anybody? No way?
Answer.
It is dangerous.
It's always dangerous. Yes, it is dangerous. Why? Because no challenge, then you'll be laid back. No challenge in life. So everything will be, you'll be in your comfort zone. You won't be improving yourself. Siapa yang jawab ketuk kepala sikit Okay, in terms of electronics atau electricity lah excessive heating of the power supply is what is concerned here. Why? Because current it is not restricted. So when the current is not restricted in an EMF, so it would indirectly encourage heat to be dissipated by the EMF.
Hmm.
Okay,
Boleh terbakar ni.
boleh terbakar, boleh meletup. Kalau standard bateri macam you ambil bateri yang besar kan, apa bateri yang besar tu berapa volt kan? Saya dah lupa dah. Kalau double A berapa volt kan? You take the 9 volt yang kotak tu kan. You take yang bulat besar tu kan. Lepas tu you arrange banyak-banyak, lepas tu you main dengan satu wire. Try connecting it and try doing it outside your house. Dia buat practical. Question number 2.
Boleh try ni.
Boleh. A cell of EMF 5 volts is connected across a length of wire of resistance 2.6 ohms. A high resistance voltmeter placed across the terminals of the cells measures 0.85 volt. Calculate. Okay, before we calculate lah, can anyone draw me the equation, the circuit for this question? Draw. Anyone can draw. Or do you want me to draw you out? Okay, the question, which one will be heating up? The components or the answer is the component of the internal resistor as well as the power supply. Okay, sebab dia short circuit. So kalau short circuit maknanya current will not be flowing into the electrical appliances connected to it, the components. But instead the power supply itself, we are compromising the power supply. Siapa yang tanya tadi? Tak sempat tengok. I just saw the question. Tapi tak perasan pula dia punya penanya. Okay, Shazrina. Okay. Memang ada dua Shazrina. I thought the other class pun ada Shazrina. Ini Shazrina lain
One only.
One only. Just now macam ada Shazrina juga.
Adrina.
Yeah.
Okay. Memang dah pening tadi. Alright. Okay, anyone? I'm still waiting.
Still here, sir.
Draw. Come on. Draw me the circuit.
Who wants to draw?
Yeah, we've got 4 participants who can annotate right now.
Sir, can I try?
Yes, you can.
Oh, who's? That's not me.
Oh, you're not the purple one.
No.
Yeah, that is Kalisha.
It's okay. You can actually draw it in another without being influenced. Okay, this is quite cantik juga kan dia drawing kan, macam straight je.
I'm surprised as well.
Oh, lepas dia square tu memang boleh tak buat square tu dash lines?
Oh no.
Tak adalah saja. Okay. Alright, this is actually the correct diagram lah. This is actually the correct diagram of the circuit that is being described by the question. So we've got a cell of EMF 1.5 volts connected across a length of wire of resistance 2.6 ohms. So we assume that this is the high resistance wire lah kan. Sebenarnya wire ni sebenarnya kita akan lukis macam ni lah kan. So where is the voltmeter?
Across the
Can you draw the voltmeter? Where is the voltmeter? And label which are the values of 1.5, 2.6, and 0.85. Okay, thank you very much. Dia kata high resistance voltmeter placed across the terminals of the cell. So terminals of the cell bukannya terminal of the DC supply but the EMF as a whole. So dia akan jadi dekat sini dan juga dekat sini. So here you will have positive and here you will have negative terminal gas. Okay, thank you very much. So here the value is 0.85 volts. Thank you for the label. And then this is 2.6 ohms. Is this the same person? Is this Kalisha as well?
Yes.
Okay. So you differentiated the thickness of the
It suddenly changed.
oh, it suddenly changed. Unintended. Okay. Another question. Why is it mentioned here high resistance voltmeter? Anyone?
Because so that the current doesn't flow through the voltmeter.
Thank you very much. So that the current will not be flowing into the voltmeter. So dia punya current flowing dekat voltmeter tu ada kan sikit, tapi dia resistance tu negligible kat situ. And you can actually play around with the Kirchhoff current law here, where the current entering the node in which it branches out to the voltmeter as well as length of wire of resistance 2.6 ohms, where the amount of current going into the node must be equal to the current going up of the node into the voltmeter as well as the length of wire. But in this case, all of the currents are actually conserved into the circuit, within the circuit itself. Okay. All right. Thank you very much. It's good work. So now moving on. So this is the circuit yang memang ada lah yang kita tengok tadi pun lah. So we have to calculate the potential difference across the internal resistance. So that means we want to find out the value of V small r. Here. Betul? So how do you do this? Potential difference across the internal resistance of the EMF. So sebenarnya yang ni kita guna Kirchhoff voltage law ataupun Kirchhoff second law, which is E is equals to V small letter r plus V capital letter R, in which V capital letter R ataupun V external, the potential difference of the external resistor is equals to 0.85 volts. So you put in values, ataupun first you rearrange, sebab KVL states that E must be equals to VR plus VR. Cumanya kita nak cari the internal resistance of the potential difference of the internal resistor. So the answer is 0.65. So in order to do that, macam mana kita nak tahu the internal resistance? Sekarang kita tahu dia punya voltage. So kalau kita nak tahu the resistance, kita kena give the current, betul tak? Cumanya nak
Current.
how do you find out the current? We know that these two resistors are actually arranged in series, so to speak lah, because walaupun tak adalah kita nampak dia punya resistance tu kat luar macam physically dalam circuit ni, sebab dia punya supply in real life dia taklah macam resistance macam tu kan. Tapi we can safely assume that the internal resistance are actually arranged in series with the external resistor. So kita boleh tahu dia punya I kan. Cumanya kita kena be wary of the value of potential difference yang kita nak guna. So we can either use I is equals to E over R plus R. Tapi problem dia, the value of R. Sebenarnya kita nak cari value of R. So we can actually use the voltage across the external resistor because we are given that 0.85 volts. And we are given the value of the resistance of the external resistor at 2.6 ohms. Are you guys still with me or am I going too fast?
Yeah, okay.
Okay.
Okay. If you guys tak dapat nak catch up, I'll send you guys the video. Okay, so the current generated from the wire flowing in and out of the EMF is actually equal to I VR over R. Kenapa VR over R? Sebab kita ambil the voltage across the resistor guys tu, the external resistor. Because we are given that value, 0.85 volts. And then we know the value of the resistance because we are given that as well. So going into the external resistor must be equal to the current going into the EMF and the current going into the internal resistor, because they are arranged in series, and also because it obeys the Kirchhoff current law, because Kirchhoff current law states that the total number of current entering a node or a component or a branch must be equal to the total number of current leaving the node, branch ataupun component itself. So kalau benda ni dalam series, maknanya I into the R must be equals to I out of the R. So the internal resistance of the cell, we can use V equals to IR, where R is equal to 2 ohms. Is that okay? Okay, moving on, question number 3. So this diagram shows a potential divider circuit. So what is a potential divider circuit? A potential divider circuit is a circuit where it divides the original potential difference that is provided by the voltage supply. So in this case, the requirement for a circuit to be considered as a potential divider, it must have more than one resistor. Sebab kalau dia ada satu resistor saja, dia tak jadilah potential divider kan, because the potential difference supplied from the supply here must dia akan transfer entirely into the single resistor unless dia ada internal resistor. So sebenarnya EMF dia lebih kurang macam divider circuit juga, sebab dia ada internal resistance dan dia ada external resistance. So dia dividekan dia punya potential tu across both of the resistors. Tapi kita taklah cakap dia potential divider circuit because EMF dia punya supply kan. Sebab resistance tu internally, dia bukan yang outside the circuit. Cuma for the sake of schematics, kita draw lah there is an internal resistor. Okay, for this, we've got a 6 ohm resistor and an 18 ohm resistor. So the battery has negligible internal resistance, and we have to calculate the potential difference across the 6 ohm resistor. So here, there are actually multiple of determining the value kan. Jalan untuk mencapai satu result tu bukan satu saja kan. Dia ada banyak-banyak jalan. So I'll be showing 2 methods. One is the manual, step by step, and the other one is actually just straight away using the potential divider punya equation. Tapi sebenarnya these 2 methods are intertwined between each other because the potential divider formula actually originated from this method. So this manual method ialah yang kita kena calculate the current kan. So here we can have 2 separate voltmeters across both of the resistors. So the overall current flowing into the circuit, first we have to simplify the circuit. We have got 2 currents in series, 2 resistors in series, combine it into one. So the I value is equals to 5 over 24 amperes. Okay, saya tak mahu lah sebab dia punya decimal places tu macam panjang kan. And then plus the current into R6 ohms in series would generate a potential difference of using V equals to IR. So V, plug in I into the R, the value of R6, so you will get the value of V6 approximately equals to 1.3 volts, near to significant figures. So this is the manual way. That means you break it down, you've got 2 resistors, you combine it into one, and then you find out the value of the current, and then you multiply it using V equals to IR, safe, you will get it. Tapi there is another method kan, which is using the potential divider formula straight away.
Unsafe.
It is actually, taklah nak kata unsafe. Dia kadang-kadang kalau tersilap pilih value of the resistor, dia akan catch you kan. Dia faster way lah, plug in the values kan. Cuma dia terbalik lah kalau just make sure kalau nak guna potential divider formula ni, is the resistor in series or is it in parallel? So you kena differentiatekan benda tu. So nak tahu senang mudah sebenarnya ialah kalau dia adalah resistor that we want, so that value of the resistor must be on top as the denominator kan. The total must be, the total resistance of the circuit of the loop must be the denominator. Okay. So yang ni sepatutnya dia guna V in and V out. Cuma yang because kita nak tahu V out dia V6 lah sekarang ni kan. So the V in ialah 5 volts. You just plug in the values, so you get 1.3 volts, two significant figures.
Okay.
Right. This question is almost similar to question 2. Tiga part kan, A, B and C. So A and B is actually exactly the same. So you just repeat the values. Sebenarnya dia guna terms yang to make sense of what is actually happening in an EMF circuit. So first we have to calculate the lost volts, which is actually referring to the potential difference across the internal resistance of the cell. So walaupun dia statekan kat sini the EMF value is 1.4 volts, but effectively does not supply the entire 1.4 volts into the circuit. Why? Because dia ada internal resistance. So dia ada lost volts. Dia macam kita tengok dia punya bateri tu, dia kata dia boleh supply 3 volts contohnya. Tapi bila kita letak voltmeter kan, kita tengok kenapa tak dapat pun dia 3 volt kan. Macam kita main dengan Unify kan. Unify dia kata 100 Mbps. Tapi sekali tengok siput kan, macam siput kan.
Oh, tipu.
Scam.
Tapi nak katanya dia inefficient je lah kan. Inefficiency.
Somewhere.
Okay. So potential difference across the ni sama. So you just use the same equations dalam question 2. So the answer is 0.59 volts for the potential difference of the internal resistor. So the value of the resistance sama juga. First you calculate current and then you calculate the internal resistance using V equals IR, you get 500. So benda ni sebenarnya you can play around to check whether is this correct or not. Contohnya you can actually reverse engineer in order to obtain back the value of the 1.4 volts. You dapat tak dia punya Kirchhoff voltage law? Macam ni you nak dapat balik 1.4 volts tu? Contohnya you dah tahu R value dah 5.3 ohms kan? So you add this 5.3 ohms with the external resistor, which is 7.3 ohms. So you get 12.6 ohms. So 12.6 ohms, you multiply by 0.11, you should get roughly around the total EMF value of 1.4 volts. So that's how you check your values. Faham ke?
Faham.
Saya dah jadi robot lah. Sebab tak boleh nak interact sangat. Dah jadi OKU. Satu tangan mendukung anak. Boleh nak de-animated juga. Dia jadi macam patung sikit. Only my mouth and my left hand can move. So bear with me lah So apa yang saya cakap tadi tu lebih pada macam mana you nak check sama ada jawapan you betul ataupun tak. So macam mana you nak check jawapan you betul ataupun tak, kan dia punya entire voltage must be 1.4 volts supply the entire circuit. So macam mana dapatkan balik 1.4 volts tu, you've got the current and you just have to add the total resistance. A circuit that contains two resistors arranged in series. Sebab tu 5.3 plus 7.3, you'll get the entire resistance. And then you multiply by the current, you should get 1.4 volts. Kalau you tak dapat 1.4 volts, you claim balik duit dekat saya. Apa entahlah. See, the ratio, which is the ratio between power dissipated in the 7.3 ohms wire against the total power dissipated by the cell. So yang ni sebenarnya kita nak cari dia punya efficiency lah juga lah kan. Maknanya we've got the external load at 7.3 ohms. We just have to determine the value of the power on that wire and the total power dissipated by the cell. So how do you do that? We know P equals to I squared R. So P wire is equals to this one. And then the P total, you have to add the entire resistance, the total resistance within the circuit lah kan. And then you get the efficiency roughly around 58%. So dia apa? A total of 42% of power is actually used up, lost because of the resistance. So is it efficient or not? So it's up for discussion lah kan?
Yeah.
Sebab dia almost half. Dia boleh performance dia separuh saja. berbanding dengan separuh saja of the power from the cell is being supplied into externally to the external load. Efficient lah sebenarnya. Alright, question 5. Cells are connected in series. Each cell has EMF 1.4 volts and internal resistance of 0.38 volts. The combination of the cells is connected across an external circuit of resistance 1.8 ohms. So sebenarnya benda ni, question ni sama je circuit yang sebelum ni dah lukis kan, yang Kalisha lukis sebelum ni, sama je, cumanya dia ada dua cell instead of one. Okay. So sebenarnya tak perlulah kita lukis dua cell dengan dua resistance tu. Cumanya kita just kena take note yang cell and resistor tu represents double the value that is being stated in the questions. So instead of 1.4 volts, dia 2.8. Instead of 0.38, sebenarnya dia 0.76 ohms. So sebab dia kata two cells kan, dia kata kat sini. Yeah. So question part A, dia kata the potential difference across the external circuit. Maksud external circuit tu, that means across the 1.8 ohms resistor lah. So the current flowing, first we find out the current, sama juga. So I equals to ET over R plus RT, where ET equals to 2E. Kalau kita assume E sama dengan 1.4 lah kan. Kalau you dah awal-awal lagi define E equals to 1.4, 2.8, tu cerita lain lah. Cuma to be safe, I define it this way. And then you get the value of the current is 1.094 amperes. So we'll just, in order to get potential difference, you get formula V equals to IR kan. So you get the value of the R, 2 volts across the external circuit. Okay, sama step dia dengan question number 4 dengan question number 2 sebelum ni. So kalau you dah lost sejak dari question number 2 lagi, so I believe right now you are memang tengah screen saver mode lah. Tengah macam tunggu. So hopefully you catch up lah kalau siapa yang tengah screen saver mode. Ada ke yang tengah screen saver mode?
Lumayan.
Ucuk. You sure?
Dah. Alhamdulillah, terima kasih Iqbal. Ada lagi ke Iman?
Very good, man.
Kau good boy.
Ada lagi ni. Anyhow, kita proceed lah Okay. Question part B, the potential difference across the cells of each cell. So soalan ni tak susah. Dia lebih pada bahasa Inggeris kan. So kena attend lah IELTS class dengan dengan bersungguh-sungguh apa kelas bahasa Inggeris kan. So dia kata cell, maksud dia apa? Dia nak tahu only 1.4 volts Walaupun kita dah awal, sebab tu I define it as 2E. Okay. And then multiplied by 2 double kan semua benda ni. Okay, so potential difference across the terminals of each cell, we can use Kirchhoff voltage law. So VR equals to E minus VR. So VR sama dengan 1.4 volts minus IR. So here you get the voltage across the terminals of each cell is going to be equals to 0.98 volts. Boleh ke?
Yes.
Alhamdulillah.
Dia boleh.
Boleh land. The diagram shows the potential divider circuit. The voltmeter has infinite resistance and the battery has negligible internal resistance. And the diagram is shown below. So first we have to calculate the variable resistor is set on its maximum resistance of 200 ohms. Calculate the voltmeter reading. It's quite straightforward kan, betul tak? Yang ni you boleh guna potential divider punya formula ataupun you boleh buat manual. Cumanya saya gunalah formula tu sebab senang sikit. So V out equals to RV over R plus RV times V in. Substitute the values, so you get V out approximately equals to 3.2 volts. Okay.
Yep.
Boleh. Sebab divided, the potential is divided between two resistors. Resistor 1, 180 ohms. Then kita ada variable resistor is set at 200 ohms initially. Okay. Part B. This is where it gets interesting lah. So the resistance R of the variable resistor is gradually altered ataupun reduced lah, from its maximum resistance value of 200 ohms to 0 ohms. So now draw a sketch graph to show how the voltmeter reading changes with R. Masa kita dah habis ke?
Belum sir.
Lagi 5 minit kan? I need to speed things up. So, macam mana kita nak graph, sketchkan graph ni? So the formula lah apa? Ataupun the equation of the curve, equation of the graph. So kita gunakan V out equals to the potential divided circuit main formula. So yang ni dia tak boleh guna current yang manually lah. Sebab kita nak tahu relationship between V out RV, the variable resistance. It is actually almost similar to a curve y equals to x over 180 plus x times 6. Okay. Ini apa? So as RV approaches 0, V out will also equals to 0. Ataupun dia akan approach 0 juga. Why do we know this? Because we plug in the values. So you can actually tabulate your data using a set of values. Contohnya here you use the RV value starting from 200 into 0. Probably you can use a spacing of 50, 10, bergantung. Sebab yang ni kalau dalam kalau dalam online ni guna Excel je lah kan, senang. So this is the answer. Okay, curve dia akan macam ni lah, with the origin 0, 0 set at the center point. So dia approach to 0 tu when you decrease the resistance value kan. So decrease 200 to 0. But when you sketch it in a graph, it must be from the origin 0, 0 to 200 kan. So the graph nampak macam increasing, tapi sebenarnya the decreasing occurs from right to left.
Separate.
Okay.
Right.
No questions? Moving on. Question 7. Diagram shows a simple electrical thermometer based on NTC thermistor. You don't have to be intimidated by the terms. Just focus on what the question is asking. At 30 degrees Celsius, the thermistor has a resistance of 2.4 kilo ohms, and this increases 130 ohms at 100 degrees Celsius. Two set of values kan, dia bagi temperature dengan resistance. So tak suruh kita pilih sebenarnya, you nak ambil 430 ke 2.4 kilo. So macam mana kita nak pilih? Kita depend on the question is asking what. So dia kata the battery has negligible internal resistance. Calculate the maximum input voltage into the data logger. So here kita nak kena tahu data logger tu is connected to what? Is it connected to the thermistor or is it connected to the external resistor? So based on the circuit, it is actually connected to the external resistor, not the thermistor. So in order to get maximum input voltage, the resistance of the thermistor must be minimum or maximum?
Minimum.
It must be minimum. Sebab minimum resistance will give minimum voltage. Kan? So minimum voltage at the thermistor will give a maximum voltage at the external resistor that's connected to the data logger. So dia inverse. So blah 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 blah. So it's either you take 430 ataupun 2.4 kilo. Jangan terpengaruh pula 2.4 kilo. Kita ingat kan, kalau baca cepat-cepat, oh ni 2.4 ohm saja, sikit kan. Tapi sebenarnya dia 2400 ohms. Dia agak cheeky juga kan soalan ni kan. Dia cuba nak trick kita kan, 2.4 dengan 430. Kita dah tahu dah ambil sikit, kita terambil 2.4. Tersilap lah. Siapa yang tak convert kilo tu 1000. So using the potential divider circuit formula, so you get the value V out is 4.5 volts approximately equals to the nearest two significant figures. question. So it's completing a table and then you sketch it out. So a chemical cell, 1.5 volts, internal resistance is connected across a variable resistor of resistance R. Sama dia punya setup dengan previous question 2, 4 and so on. So we have used the correct formula. So in order to complete the table, first we just finalize the equations that are concerned and plug in the value sajalah. So kita dah tahu first dia minta current and then dia minta potential difference at the external resistor. So kena play around with the equation. So once you finalize the equations, you can actually tabulate the data lah. Okay. So dia masukkan. And for this question memang dia dah bagi tahu dah what are the values that they want. The I, which is the current drawn from the cell. V ni mungkin confusing it. Terminal PD. Terminal PD ni lah the potential difference supplied, the effective potential difference supplied at the external resistor ataupun the variable resistor. Okay. Okay, and then the power P equals to I squared R. So from here, we go to the last question which is with the aid of this graph, describe how the power dissipated by the external resistor affected by its resistance. So first, you plot it out. When you plot it out, dia akan ada curve macam tu. Dan kita akan nampak dia punya maximum at the resistance is at 0.5 ohms. So coincidentally, tak coincident sangat, this value of 0.5 ohms is actually similar to the internal resistance value of the cell, which is at 0.5 juga. So what can we conclude with this? Based on the data and the sketch graph, data tu maknanya apa? Yang table tadi yang kita ada kan. Maximum power is reached when R equals 0.5 ohms. This resistance value is actually equal to the internal resistance R of the cell. Our conclusion is to deliver maximum output to an external load, its resistance must match the internal resistance of the supply. Generally, that's what we do. So sebab tu kita ada variable resistor tu untuk kita nak test test out this hypothesis kan. Maknanya betul ke tak when the value of the resistance of the external load matches the value of the internal resistance of the supply, it will dissipate maximum power. Sebab tu kita take different readings of the voltages for the resistance at different resistance value, and then kita plug into the formula for power, you get memang betul kalau dia punya resistance tu sama macam the internal resistance, dia punya power will be maximum. Okay, and that concludes our session. Wallahu a'lam. Do you have any questions?
No, sir. I don't.
Alhamdulillah. So we got a 19 over 19 attendance here. Good. Alhamdulillah. So you will have the quiz on Monday. You can start answering them as early as 8 a.m. The latest is at midnight, macam biasa. Okay. Apart from that, I have received all of your feedback notes. Thank you very much. So I'll see you guys probably on Tuesday for the feedback session, discussion on your quiz questions.
Okay.
And you would like to request an additional remedy class, then you are welcome to do so. We can always discuss, insyaAllah, anytime. Kalau siapa ada soalan pun boleh tanya. Alright?
Right.
Yeah.
Okay, so sorry for taking 5 minutes extra time. So I see you, insyaAllah.
Bye, sir. Take care.
Subhanakallahumma wa bihamdik. Asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asri innal insana lafi khusrin illa alladhina amanu wa 'amilus solihat wa tawasaw bil haqqi wa tawasaw bis sabr. Assalamualaikum. Bye bye.
Thank you, sir.